Hello, this is the media assignment lecture for F3 lines. This is the overview. Part 1 is this one's going to have two parts, part 1 and part 2, because F3 has a a lot of material, but not very difficult. It's a lot of review. This is actually Math 103 as well. And but I decided to divide this video into two parts, simply because there was so much of it. And so what we're going to talk about on this part 1 is two concepts, slope and the average rate of change, but in essence they're pretty much the same thing, and I'll kind of explain how they're related once I get down here. But we're going to begin with slope, and we're going to begin with the definition of what it is. Now, the definition of slope, simply put, is just the steepness of a graph that has that's a line has 2 points through it. So it's the steepness of that line. So it looks something like this. So if you have two x coordinates, two ordered pairs, x1, y1, and another one up here, x2, comma, y2, and you have a line. Now, depending on where this line is situated, if it's if it's kind of horizontal or more steep, or horizontal or vertical, is going to determine what the slope is. And so what we're doing is, based on these 2 points, we're trying to determine what the steepness is. And a lot of times when people ask, well, when I say slope to you, what do you think of? And they think, well, it's the rise over the run. In essence, that's what they're saying here in words, but the rise over the run is based on that formula. And so it's the steepness. Now, when a line is going like this, left up, left to right, that slope is positive. And I'll tell you why in a second, because when you apply the formula to it, the slope will be a positive number. So this becomes what they call the rise. And this becomes the run. So when you say slope, M equals rise over the run, the rise is the difference between, again, when we were talking about, when we were doing this before, this is the y1 coordinate and this is the y2 coordinate. So when we were trying to get the distance, we were looking at the difference of the y coordinates, how far is it apart. So that's kind of the same thing. So the rise is y2 take away y1. And then the run is, here's the x coordinate of the first point, and here is the x coordinate of the second point. And the difference between x2 minus x1 is that run, is that distance. So that becomes x2 minus the x1. Now, the thing is, when you're doing it this way, the slope will be positive. Now, the thing is, when the line's horizontal or vertical, a lot of people get those two mixed up. Well, when you have a line that is horizontal, the y coordinates are the same number. So this one will be x1 comma y. Notice I don't put the subscript y1 down there, because that coordinate on that y are both the same. So x1y, x2y. I don't say x1y1, x2y2, because this y coordinate and this y coordinate are identical. So when you try to find the slope, the difference of the y's over the difference of the x's, well, since the y's are the same thing, it's 0 over x2 minus x1, which is 0. So horizontal lines have slope that is 0. Now, if it's a vertical line, that means the x coordinates are the same. So this one we'll call x comma y1, and this one's x comma y2. Again, notice that there is no x1, x2, because the x coordinates are the same. And so when you try to find the slope of that, it's going to be the difference of the y coordinates, so it's y2 minus y1 over x minus x. I don't say x2 minus x1 because the x's are the same in a vertical line. So then you have y2 minus y1 divided by 0, and you cannot divide by 0, so the slope is undefined. So on vertical lines, the slope is undefined. Okay, so a lot of people get them mixed up, and there isn't an easy way to remember it. It's just horizontal, 0, vertical lines, undefined. So, I mean, the only way I could think of maybe getting it in your head is vertical is a letter way at the end of the alphabet, so it's undefined. UV, so UV light, so UV, so undefined, vertical. Whatever works, guys. It's something way you can remember them. So vertical lines have undefined slope, and horizontal lines have 0 slope. All right. So that's this. And then when the lines are like this, and again, I'm going to be doing some graphs and some slopes of some problems once we get into the second, third, fourth videos down the line, and we're going to be doing some examples. And you'll see that the line that goes up will have a positive slope, and the lines that are going down will have a negative slope. But when it's horizontal, it has a 0 slope. If it's vertical, it has an undefined slope. Now, let me give you a little bit of history of the letter M. A lot of people ask, why do they use slope with the letter M? And I asked my high school teacher this question when I was many decades ago. And she said, well, they don't use S because S looks like a 5, and that wasn't my question. I think she didn't know what the answer was, but I did a little bit of research, and the reason they use M is because many centuries ago when this was developed, it was called modulus slope. Modulus, M-O-D-U-L-U-S slope. And as time progressed, the word modulus was dropped off. So we just left with the word slope. But the word modulus begins with the letter M, so that's how it kind of carried on. It's like an appendix, if you will. And it just kind of attached to it. And that's where the history of M, that's why it's called M, is because it wasn't always called just the word slope, it was a modulus slope. I think it was Greek or something like that. But it was modulus slope, or Latin, maybe it was Latin. But anyway, it doesn't really matter. But modulus slope, M, slope. So that's the reason it is. That's the history of M. But and then the second one is called the average rate of change. And there's a lot of similarity between these two. The average rate of change is essentially what slope is. It's the change in y. This is delta y over delta x. This is, you read this as the change of y over the change of x on the average. And the reason they're taught together is because when you're talking about slope, you're talking about lines, but points on a line. When you're talking about average rate of change, you're still talking about 2 points. But the graph that connects those 2 points is not necessarily a line. It could be some other graph, like a parabola, where the slope isn't always essentially the same thing. So for example, you could still have an x1, comma, y1 down here, and an x2, comma, y2 up here. But the graph that connects those might be something that looks like this. It's a parabola. And what you're doing is you want to know what the average rate of change between this point to this point. Well, if you notice, the graph isn't the same as a line where the graph's slope is the same thing. For example, if the slope here is 1/3 through here, it's 1/3 through here, 1/3 through here, 1/3 through here. It's uniform. It stays the same. Well, you can't talk about slope of a parabola because it doesn't stay the same. Parts of the graph has a very shallow slope, and some of it's pretty steep. As a matter of fact, this graph is going down on this side, so it's going negative, and then it's going up back on this side. So if you're going to talk about slope between these 2 points on this graph, since it's going down, it's going to have a negative slope, and over here it's going to have a positive slope. So it's just not, you just don't talk about slope with non-lines, like a parabola. But you would talk about the average rate of change. So when you're talking about from here to here, although some portions are shallow and some portions may be even negative, what you're trying to do is figure out the average rate. I don't know if you guys ever been like to Colorado or Arkansas. You'll see a sign that every once in a while will say, if you're up in the hills, and it'll say, the road rises like 2.5% grade over the next 5 miles. So that means every 100 feet, the ground of the highway rises 2.5 feet for every 100 feet. Now that doesn't say the road stays that same slope all the way. It curves down, up, and down, up. But by the time you get down to the end of your destination, that road has risen 2.5 feet every 100 foot. Some parts you might rise 3 or 4 feet per 100. In some parts you might actually be going back down. So, but on the average, it rose 2.5 feet per 100. So it's the same thing here. This is like, I think that this is like a valley going through Branson. Parts of it is, not very shallow at the bottom part. But then as you go up, it can get really steep. So that's what's going on. Now, well, how do you do it? How do you find the average rate of change? Well, you can only, at this point, you can only find the rate of change between 2 points. So it works the same way. You connect those 2 points that you have with a line. And so the average rate of change essentially is the same thing. So, but you don't call it M because you're calling it, we'd be calling that slope. So we came up with an acronym, AROC, average rate of change. How about that? Aren't mathematicians, so creative? So average rate of change, and it equals the change in Y over the change in X. But the change in Y is really Y2 minus Y1 over X2 minus X1. So it's the same formula because you're still finding the average rate of change. That doesn't mean, though, whatever the average rate of change is the same all the way on this graph. I mean, if AROC was 1/3, that doesn't mean it's 1/3 all the way. That means on the average, it averaged out. Part of it might be at 2/3. Part of it might be at 1/6. Part of it might be at 2/3, or 4/3, or even. But on the average, from this point to this point, it rose 1 foot every 3 feet. So that's what the average rate of change. So from your point of view, you're not going to see much difference between what the average rate of change is and the idea of slope. But you got to get it in your head that average rate of change is dealing with graphs that are not lines. Whereas when you talk about slope, it's always the slope of a line. You never say the slope of a parabola. It's always the slope of a line. So that's the difference. The good news for you guys is essentially you're using the same formula. So, but anyway, this is the overview part 1 of F3. My next video for this section will be part 2. And so we're still not going to be doing many problems. We're just going to give you the overview from the rest of this section. Starting video 3 in this section, that's when we'll start some exercises in the book. Okay? Thank you for watching.